Section 3.3, Applications of Quadratic Functions. The first problem is D's pig problem. D's side has a pig that presently weighs 200 pounds. She could sell it now for $1.40 per pound. The first question is going to be, what is the value of the pig now? So in order to figure that out, you have to think about what you need to know. So to figure out the value, it's 200 pounds times however it costs per each pound. So in this case, the weight times the price. And that's going to be equal to 200 pounds times $1.40, which gives us $280. So this is the price of the pig right now. Now the next part says the pig is gaining 5 pounds per week. Write an equation for its weight as a function of the number of weeks, WT. What kind of function is this? So W of t is going to be equal to, well, now you need to go back to the original problem. It says the pig presently weighs 200 pounds and is gaining, so 200 plus 5 times t, which is how much it's gaining per each week. And of course, if you were to graph this equation, you would see that this is a linear equation. The next one says the price per pound is dropping 2 cents per week. Write an equation for the price per pound as a function of weeks P of t. What kind of function is this? So P of t is equal to, well, we know that she could sell it now for $1.40 per pound. So that's what it's at currently. Minus, and it's dropping 2 cents per week, so minus 0.02 times t. And of course, if we were to graph this, this is a linear function. For D, it says write an equation for the total worth of the pig as a function of weeks T of t. What kind of function is this? So the total worth of the pig, think about what we need for that. In order to figure out the total worth, you need to figure out the price times however much it weighs. So we just came up with the two equations for that. So the total worth is going to be the weight of the pig times the price of the pig. And so in this case, we have the weight, which is 200 plus 5t, times P of t, which is 140 minus 0.02t. Now notice if we were to multiply this out and combine like terms, we would get this is equal to negative 0.1 t squared plus 3t plus 280. So this is a quadratic function. Which makes sense because we're doing applications of quadratic functions. For E, predict the worth of the pig after 8 weeks, 16 weeks, and 24 weeks. So that means we're plugging in 8 for T, and then 16, and then 24. So the easiest way to do this is probably just get out the calculator. And in your calculator, y equals, you're going to plug in the equation like we have here. After you have the equation plugged in, then I'm going to go to second window, and I'm going to change my window to ask, so that when I go to the table, I can just ask the values that we need. So I'm going to plug in 8, and then we need 16, and 24. You could also just plug it into your equation, that would be fine too. So if I go back to my sheet here, I'm going to add 8 weeks. We have $297.60. So 16 weeks. We have then $302.40. And then at week 24, the total is going to be $294.40. F says, when should D sell the pig to get the maximum amount of money for it? Because I'm talking about the maximum amount of money, that means I want to find the vertex of my equation. In order to find the vertex, I could do using this polynomial equation right here. I could do x is equal to negative b over 2a. And so in this case, it would be negative 3 over 2 times 0.1. When you do that, you end up with 15. Or you can go to your graph. And if I look at my graph, I know if I look at the graph right now, it's not going to be a good graph because I'm not looking at a very good window. So I'm going to change my window. Now that I have my graph, I want to find the maximum. So second trace is what I wanted to do, and we're calculating a maximum. So something to the left of where I think the maximum is here, and then something to the right. Could be somewhere over here. Enter. Oops, went a little too far. And then enter and guess. And our maximum is 15, 302.5. So that means in order for D to get the maximum amount of money for it, she must sell it at 15 weeks. So D must sell the pig at 15 weeks to get the maximum profit. Now, normally these application problems for quadratic functions is not written in this order. The reason I wrote it kind of out like this was just to show you the thought process that you can think of as you are solving these quadratic functions. Most of the time it would just be written as one big word problem, and then you would have to do each of these different steps on your own. So it's good just to kind of see the thought process that I would use in order to solve these. So let's do another one. So this is for the Star Wars fans out there. Luke and Laura problem. Luke and Laura are trapped in a room in a space station. The room is 20 meters long by 15 meters wide, but the length is decreasing linearly with time t at a rate of 2 meters per minute, and the width is increasing at a rate linearly with time at a rate of 3 meters per minute. Let L and T and WT be the length and width of the room, respectively, in meters, and let T be the number of minutes since the room was 20 by 15. Write an equation for the length and for the width. So let's start with the length of the room. So the length first time, we started with a length of 20, and we're decreasing by 2 meters per minute. So that would be my equation for the length of the room. Then for the width of the room, we started with 15 meters, and we are increasing by 3 meters per minute. So those are my two equations. Then it says, let A of t be the number of square meters in the room for positive values of t. Write an equation for the function A of t, and this really means we're trying to find the area. So the area, of course, to find it, is going to be length times the width, which in this case is 20 minus 2t times 15 plus 3t. Then it says for C, does the area of the room reach a maximum for a positive value of t? If I look at my equation, if I were to write this out in polynomial form, I would notice that I have a negative 2t here and a positive here. So I know that my quadratic term is going to be negative, which means my graph is going to be opening downwards. So I would say yes, the area will reach a maximum value since The graph opens down. Now I need to figure out this value. So a couple of things I could do. This is kind of like an x-intercept form. So I could find the x-intercepts and then do x-intercepts plus the other x-intercept divided by 2 and solve, or I could put this in polynomial form and do negative b over 2a and solve, or I can go ahead and just put it into my calculator, which is what I'm going to do. So in my y equals, I'm going to clear this. So 20 minus 2t, or 2x in this case, and 15 plus 3x. And then if I hit graph, I need to go a little bit higher in my window, so let's go to maybe 400. And then second trace, maximum value is what I'm looking for. So I want something to the left, enter, and then to the right, enter, and then enter. And notice you get your maximum is 2.49999, so 2.5, and then 337.5. So the value would be, so the vertex is 2.5, comma 337.5. So it reaches a maximum, I guess, value, and I'm going to say at 2.5 minutes. Then the next question says, when will the area of the room be 0? So the area of the room is our a of t, and that's our y value in this case. So that means I want to plug 0 in for y and solve for t. And I can set each of these binomials equal to 0. Now notice I get 10 and negative 5 for time, but if you think about the problem, can you have negative time? No, so we're not going to use this. So this is going to be your answer. So when will the area of the room be 0? So the area of the room will be 0 after 10 minutes. So let's hope that Luke and Laura make it out of the room before that. And as I said again, normally these problems are not written out like this with all the steps ready for you to write. You kind of have to think about doing that on your own and then get your two linear equations, multiply it together to get your quadratic function, and then you have to figure out what is the question that's being asked and how can I go about answering that.